Cool. Hi, everyone. I'm Naomi. I'm lead analytics engineer at List. And today I'm going to talk to you about how we've improved quality and trust within our transformation pipeline. So who is List? List is a fashion technology company and premium shopping app founded in 2010. We have over 160 million annual shoppers with the most comprehensive range of products. We offer over 8 million items in our catalogue from thousands of brands and stores. Our analytics function is made up of analysts and analytics engineers. We work with a hub and spoke model. We have a core analytics team with embedded analysts and AEs in teams, which we call squads in our company. Our current stack includes AWS S3, Snowflake, dbt, Terraform to manage our Snowflake account, and Looker. dbt was introduced to the business in late 2019, along with Snowflake, to move our transformation out of Looker. So previously, all of the transformation had been done using PDTs in Looker in Redshift. When dbt was initially introduced, analytics would need to review all the PRs as they were the only ones with privileges in the repository. And if the table was needed to be rebuilt in production, analytics were also the people that had to do that. So this became a challenge as teams started to use dbt more and more, including engineers who are not in the analytics function. And in some cases, the role in Snowflake that had the privileges to run tables in production were given to people outside of analytics with the risk that they would do something that they shouldn't, such as delete a table. So in order to empower teams, we set up something in GitHub and Snowflake. So each squad has their own folder, and they can build their own dbt models in that folder, which is transformation logic for a table. And then we use GitHub code owners. So for anyone that doesn't know, code owners in GitHub enable teams to have privileges to a subset of the repository without being able to merge, review and merge across the repository. And then each squad has their own schema in Snowflake, where the dbt models from their folder are built. And then they've got their own Snowflake role, which has permissions to run any dbt models in their schema in production, but they can't run anywhere else. And this means that they can develop and build in silo without a bottleneck from analytics. And then finally, we have squad-specific warehouses, which are basically what you use to run queries in Snowflake. And they exist for all of the squad roles to use so that we can then monitor cost as well. And essentially, a hub and spoke model was implemented to mirror what we have in the company. So we have core dbt models, and then we've got a core schema in Snowflake, and analytics are the only people that can run those and merge PRs. And then we have teams have ownership of their own transformation logic. However, this led to new issues, and we still had some challenges that were unsolved. So the first one was that business critical tables in the core folder were still dependent on transformation logic outside of the core folder, and that was usually developed by non-AEs. And so basically the hub was affected by the spokes. So this would either lead to changes in transformation logic that we were unaware of, or PRs that were merged with errors that would then lead to issues in core business critical tables. And then secondly, there were no development guidelines set. So logic, testing, naming conventions, etc., weren't consistent across the business. Thirdly, we had CI set up, but often issues weren't caught by the tests that we had, and then we'd still have failures in production. So as an example, CI would run in the development database, which is where the developer would have been testing their code or testing their table. The code would obviously match the table in development, CI would pass, and then in production, we still have failures. And then finally, each schema contains both intermediate logic and the logic for the presented tables. And it's unclear, or it was unclear within a schema, what was the final table to query versus intermediate logic. And so we'd have people that would run queries against tables that they shouldn't, and we would, yeah, it would lead to confusion. So last year we came up with V2 of the solution. So we developed a setup that would work for us. To solve the first challenge, the hub being dependent on spokes, we basically built on what was already existing. And so within the core analytics folder, we created squad subfolders. And then the models from these subfolders are built in a new schema with the prefix core underscore. So every squad now has two schemas. As an example, product has a product schema and a core underscore product schema. So any business critical models that were core dependent are then built in this core product schema, and the logic is owned by analytics. So squads can still create pull requests, but they can't be merged without analytics. It also makes it easier for analysts to understand what tables are maintained by analytics and adhere to our best practices, and also what analytics can answer questions about based on the fact that it lives in a core schema. So now that stakeholders could easily see what tables are owned by core and that we could make sure that business critical logic was owned by the analytics function, the next challenge to solve was to make it clear what table should be queried versus what was intermediate logic. So within each folder, we created subfolders: raw for raw logic, intermediate for our intermediate logic, and then presented for our final transformation. And as I mentioned earlier, each squad has their own role, which has the correct privileges to run tables and in their own schema and then read all the other tables. So as an example, product role has write access to the product schema. And then we created a second role for each squad called squad underscore presented, which is granted read access to only the tables that have been built from a model in the presented folder. So when a presented model is run in production, we run a post hook, which is another query that's run after the model has been run, which then grants read access to all of the presented roles. So if a user wants to know what tables they should query and what tables are owned by analytics, they can use their presented role and then query any table in a core schema. The next challenge was improving our development workflow. So we wanted to create standards within analytics engineering and also improve our CI process to reduce errors in production. So the first thing we did was create a README markdown document with guidelines, which includes information about how to run DBT locally, the DBT jobs we have. It also includes things like naming conventions, testing, how to document code, etc. And then we created a PR template. So reviewers can more easily understand what they're looking at when they're reviewing. It also has a checklist of what's required at minimum for any analytics models and what we recommend throughout DBT. The document provides consistency when anyone from analytics is reviewing a PR. Before that, this also includes a document which has a list of questions that every analytics reviewer will ask themselves when they're reviewing a PR, which includes things like, does this column have tests, all the way through to, is the PR doing what's expected? So this provides consistency across the analytics function and also provides transparency to DBT developers so they know what's going to be checked when a PR is reviewed. And then the final thing was that we improved our CI process. So one of the improvements was to create a sandbox schema every time a PR is opened. So the tables that are amended can be created and then tested in silo. And we also implemented Slim CI. So the tables in the PR schema are built from tables in the production database rather than the development database to check that it will actually run in production. And we run all of the models that have been changed in the PR plus their tests and the first level of downstream dependent models. So we can not only check that it's going to run, but also check the data. And for any incremental models, which are tables that are updated rather than rebuilt when they're run, we check both the logic to build the table and the logic to update the table. Another improvement that we made to CI was that we built a macro that runs and comments in GitHub any schema changes. So we found a theme that had appeared in our production failures, where someone would merge a PR and then forget to run the necessary models in production to make sure the production table matched the production code. So most of our top models are incremental, which means that they're updated rather than rebuilt when they're run. And so if someone changed something in the code, like deleted a column, then DBT would fail until the column had been manually deleted from that table. So DBT has a parameter called onSchemaChange, which you can set to sync all columns. And what this means is that Snowflake will delete a column if it's been deleted from the code, add a column if it's been added to the code, or update data types if they've been changed for a column that already exists. And this works in most cases. So we decided to add this. However, Snowflake can't change all data types from certain data types to others. So as an example, you can't change a column from a string to a number. And so this would still break in production. So we built a macro. As I mentioned, every PR has a schema created, which runs all of the change models plus the first level of dependent models. And so this macro basically compares the data types from the tables in the PR schema against the tables in production, and then comments any changes. So the developer can check if this is expected. If it's not, update their code. And if it is, they then know what needs to be run in production. We've seen vast improvements since these changes have been made in both code quality, trust in our data, testing, and reduction in downtime. We're continuously reviewing our workflow. We actually had a meeting about this yesterday, but still a work in progress, but it's great to see how far we've come in the last few months. Thank you. Oh, any questions? Or do you want to do questions at the end? Questions? Yeah. So in reality, we've actually got 4. Reason being that we use Snowpipe and our tables are just one column with massive JSON. So we've got JSON flat, then raw, then intermediate, and then presented. I'd say from like looking around and also just previous jobs, I think everyone says presented as presented. I think intermediate gets too big if you just have an intermediate for everything else in between. But raw and intermediate, I think, yeah, depending on who's developing. Yeah. The raw ones. So we've got JSON flat just to flatten it, and it's exactly the same. And then raw and intermediate, I think it depends on the developer where they want to put it. But we've got guidelines, and we say raw should be like very simple, potentially changing names of columns and things like that. And then intermediate, you'd probably start joining stuff together and doing something a little bit more advanced. Yeah. No, we haven't. We're on 1.1. Maybe. Are you working on it? Yes. That's a tough one. I'd say the fact that it had been around for quite a few years meant that people kind of didn't want it to change. But as we started changing it, as stakeholders started realizing how beneficial it was, it made life a lot easier. But yeah, I'd say at the beginning it was a little bit like, why are you spending time fixing this? And now it's, oh yeah, this makes sense to make this better, and it makes everyone's life easier and people understand and it's clearer. I'd say like one of the challenges that we're having at the moment is that we're definitely reviewing more PRs, but it means that every PR is getting checked by someone. So we're slowing down, but with the knowledge that in the future we should be able to speed up again, because things won't be as unclear. But yeah, we definitely have to make trade-offs in terms of building new things, just so that we have a good foundation, and that, yeah, everyone knows what's going on. Yeah. Anything else? No? Cool.
Hello. Okay. Well, thank you so much, Naomi, hosting us, and for that great talk, and for cleaning up the mess I left behind. How do I get this working? Okay, so my topic's observability versus quality in data. So I work at Metaplane, which is a data observability company. And I think there's a lot of entrance in the space and a lot of talk about quality. And you have observability companies saying they're quality companies and very few quality companies in existence at all. So what's the actual problem space? So data is moving from just becoming like a what feeds BI to becoming a product in its own right. So you have data teams who are like the center of what their company are doing, providing data outputs to go into their applications and into their products. And so what we're seeing is that these data teams are having to do so much more, increasing amounts of data, increasing stakeholders, and much more use cases than before, with different formats of output required. So more data, more problems. It seems to be like a popular phrase now, but inevitably things break if we stick with our old ways. So that can lead to poor decision making by your stakeholders, loss of trust by the organization. There's a theme coming on about data trust, and lost time for the data team because you're always firefighting, going back, fixing something that broke. And I think a huge part of that problem is traditionally data teams have operated very far to the right of this diagram, where you're really in the red zone, where the difficulty in addressing any data quality issues is much higher. If we could operate much further to the left, before data enters the hands of our stakeholders, before data is touching our applications or our products, it would be much better. So I think what we're going to see over the next few years is data moving to become a first-class citizen of application development, where actually product managers, rather than treating data as like a last-minute consideration that sometimes gets chucked off at the end of the sprint, actually becomes, fully integrated into what they're doing. And I think quality and observability approaches can prevent bad data entering that red zone. It's never going to eliminate it entirely, but I think we could be 2 orders of magnitude better than we are today. So, quote from Kevin, who's our CEO, in software, there's a line which goes, treat software like cattle, not like pets. Unfortunately, in the data world, we have to treat data like thoroughbred racehorses because lineage matters. And that's so true. I could almost say from an English like mindset, you could treat data like sheep. They want to kill themselves 3 times over. So it's that kind of thinking. So origin of data observability, it's kind of got 2 parents. So one is data quality, which is a topic as old as data itself, with a lot of research originating in the 90s, which is around the time that databases proliferated really heavily from the 80s onwards. And then also software observability. So these are software that you've seen in every IT department you've ever worked at, things like New Relic, Datadog, Splunk. And these 2 fields have merged together to come to provide this new field of data observability, which is very, very new. I'd say people weren't even using that term before the year 2020. So what does data observability do? What are the typical use cases? So data observability tools watch your system for data artifacts and metadata and alert you if something has deviated from what's expected. And this is very much from a statistical viewpoint. It's not as you've asserted that it should be. This is different to how it has been in the past. This is different, taking into account seasonality, taking into account year-on-year trend, taking into account an allowance for white noise. So observability tools often suggest there could be a problem with quality, there could be a problem with your system uptime, and that they aren't quality tools in and of themselves. So what's quality assurance then? So one of the things I learned about having recently dabbled with software engineering is you can change a few characters of code and then have to write another 30 lines of testing. So test suites are like huge parts of software engineering and maintaining those pieces, those test suites. And what they do is they assert what good looks like and whether what has happened in development or in production is the case. So as you can see on the picture on the right, you've got things like DBT tests, which are tests that we're probably quite familiar with. But in software engineering, there's a whole chain of testing, unit testing, integration testing, end-to-end testing, where we do more. And I think in data, we're going to move towards doing more similar activities, although data is a different entity as well. And there's still quite a few off-the-shelf quality assurance tools. So you've got tools like Avo and Iteratively, which will monitor your tracking plan, but that's very much the very far left of the DAG. And I think we're going to have to get to a point with data where, just like with software engineering, maintaining our test suites will be a big part of the cost of building. And it's something that's quite hard to automate because it's very much assertion based. It's about your company, it's about your organization, it's about what's normal to you and what you'd expect. And that's quite hard to automate. And that's what you see with software engineering, where most test suites are built in-house. But as you could imagine from something being so laborious, you have to make a balance between coverage and complexity. It's very rare for software engineering test suites to cover every possible eventuality. So common use cases that I think span quality and observability are things like freshness. So this is like, did my DBT model run, right? From a quality point of view, you'd assert that my model should run between 8 a.m. and 10 a.m. And if it didn't, that's a problem. Whereas observability would not assert anything. It would just say, well, usually it's run between this window with a 95% confidence interval. And if it hadn't, I'll let you know. And this is the same is true for many of these, where things like schema change, like you may not have a quality assurance rule for schema change, but if a column drops off a table, an observability tool will tell you, your column dropped off your table. And then there's also things around the nature of data, like silent problems where nothing has broken, but something has changed. So things like your split of marketing channel traffic, for example. Suddenly your paid channel's gone up to 40% from 20%. Now that may not necessarily break a quality rule, although you could make a quality rule for it, but it will trigger an observability problem. And so here's some specific examples which are quality assurance. So like I said before, managing the tracking workflow, this is where tools like Avo, Iteratively, protocols come in. But I think one area which I'd really like to see more of is testing event data, which is becoming more and more the source data for a lot of our data systems, which is in some kind of semi-structured event. That they all have schemas, and we should be recording those schemas somewhere and testing whether new data coming in fits that schema or not, and then blocking it from going into production data if it doesn't. And also looking at whether code changes affect the quality of the data going into production. So this is the sort of thing that could happen in a CI flow where you've made a change to a data process and that changes the nature of the data that's output from the process and diffing between before and after. So you've got Datafold, for example, doing that, and they've open sourced their tool recently. So which is needed? In reality, you need both. So software has both. They have their test suites, they also have their monitoring tools. And I think data is in the place where we need both as well. It's definitely worth investing in your test suite to ensure that your core quality expectations are met. But I think it's also worth having an observability tool to watch your back and to check the things that you're not expecting. And that's my presentation. Any questions? Yeah, so I think that's where those tools like Avo and Iteratively come in, where you're building a whole workflow around when a change is made by application developers, we're thinking about what that will do to the data and then defining what we should expect in terms of testing and coverage. And if we trigger this thing on the application, it should generate this event. There shouldn't be no event. And if there is an event, it should have these fields and these structures inside it. So I think you can actually do stuff there as well, because ultimately when that product manager is looking at that change they're making, they're also thinking about, well, I'm changing this data, but I'm changing this data because I also want to measure something at the end of it. So if you know at that point what the metric is, why not define it there? Think about what the metric is and start measuring it as part of the development flow. And you could also push those metric definitions onwards. Otherwise, you're always kind of chasing your tail as data people, trying to go back to the source data, trying to understand how to use it to define metrics properly. Whereas if it's defined up front, it's a lot better. Anyone else? Going for the headline act? Okay. A new version. Okay.
Just talk amongst yourselves. Sorry. I think it would be worth it. Let me send it to you.
Yeah, she's mainly on like the Optimist as well. Yeah, I can't share the message. Can I share the deck? Oh, wait, hang on.
I'm
Oh,
on
no, I can do
Zoom,
it.
so I'm just charging
Yeah.
rather than.
Got it?
All right, I think we're in business. I've never done that before. It's actually really like empowering thing to do. Well, cool. Thanks everybody for having me here today. My name's Taylor. I am head of product at Count. At Count, we're building a whiteboard for data. If you want to talk to me about that later, I'm happy to give demos, but my talk is actually not about that at all. And yeah, I'm going to be talking about agile analytics. I think a good alternative title would be "What if Agile didn't suck?" So I think that's kind of what we'll be talking about. So a little bit of background about me and how I got into this talk. So I am an engineer by background. I got into data after my first job in engineering, just started really doing all the data stuff for the engineering team, really enjoyed it, joined the data team, and I really quickly found actually being on the data team kind of sucks. And so all the things that I loved about data on the engineering team were gone on the actual data team. And that to me had everything to do with how to work with the business. All the ways that we worked with them didn't work. It didn't work for them. They didn't feel like they were getting what they wanted. It didn't work for us. We were very frustrated. To give an example of what my life was like at that time, it's pretty common. I imagine a lot of you guys feel this, where you get asked to do something, you go away, you're really trying to do it, you're trying to listen to what they want, you're trying to do, really take into account what they've asked for, and you take all this time, and then by the time you get it to them, it's completely changed and you're starting from scratch again. It's very frustrating. So I often felt like this, where I felt like the things that I wanted to do and the things that I loved about data were in direct conflict with the things that the business wanted me to do. And so I actually, you guys don't know me personally, but I'm a very even-keeled person. And I decided kind of on a whim to leave this company. So my first company, not the one I'm at now, still there, the one I started with. And I said, I don't want to be in data anymore. I just don't think this is for me. I don't think it matches with how I want to work, and left. And I left, I moved to London. It's like gonna get away from data. I'm gonna do something else. Obviously it didn't work. I work for a data company now. I didn't get very far. But I've been wrestling with this question since then of why is this so painful? Like, why does this, am I the only one who feels like this? And over the last 5 years at Count, I've talked to so many people doing research and stuff. And I talked to people before the session who were talking about the same problems. And so I know that I'm not alone. A lot of people feel like this. And I even heard a lot of David, what you were saying about trust and how do you build trust and how do you, ultimately what our goal is with data is how to be effective for the business. So how do we actually do that? And I quickly have data to prove that being an analyst sucks. This is some Stack Overflow survey data. And so out of all of the different options, being an analyst, analysts are more dissatisfied than data engineers or data scientists. Good for data scientists at the bottom there. And I also looked at, let's say you're like a developer, but you're also a developer who does data. How much more dissatisfied are you because you do data? And if you are, if you add data analyst to any position, you're like it's like the worst thing you could do. I mean, apparently not the worst. Being a game developer is actually the worst, but it's pretty close. So anyway, in case you're wondering if it sucks to be an analyst, it really does. And just to kind of give a brief overview, I think we all know this, and these are kind of the common things that I saw, not just in my story, but talking to a lot of people now at Count, that this is kind of the path that teams go through in terms of like how your culture just gets so kind of deteriorated. And so these are just the pain points that I think we all feel. So there's just being detached from the impact of what your work is actually doing. You feel like you're a task master just trying to do stuff that people ask and you don't know why you're doing it. There's constantly shifting requirements, which is what I showed before. You have very formalized communication with your stakeholders a lot of times. You might force people to request things through like a portal, and you might say like, no, we don't do ad hoc requests or something like that, or you have to talk to us through the Slack channel, something like that. So it's not like open communication. It's very like siloed. And the one I think really tucks on what I'm sure you guys all care about here today is mistrust of data. And so I think a lot of data quality stuff is trying to address this trust issue. And eventually get to a point of apathy where just nobody talks to anybody anymore. And that's where I was when I left. So hopefully nobody's there, because that's a very bad place to be. So the question, what does this have to do with Agile? So in all honesty, if you had asked me 6 months ago what I thought of Agile, I would have said it's complete BS and it's terrible. And I didn't want anything to do with Scrum or anything like that. I thought it was just corporate kind of consultants coming in and telling me what to do that didn't understand what our problems were, what we were trying to do. And late last year, I don't know why, I just started researching Agile to learn more about it. And out of the history of Agile, I don't know if you guys know much about the original group that started it. So there was this group of developers, software developers, and they were really frustrated with their experience building products. In particular, they're frustrated with rapidly shifting requirements. They were frustrated with, they didn't enjoy how they were working. They didn't get a lot of value out of it. And so they just decided, they went to Utah, of all places, or something, and just like sat in a room and were like, how would we fix this? If we could do anything, how would we fix it? And I'll show you a few things about what they did in their manifesto, which is a bold move to make a manifesto, but they did it. And they did three things in particular that I was really connected with anyway. So the first thing they did is they were very goal oriented. So they said, it's our goal as software developers to make great products. That's what we do, make good software. The second thing they did was they focused on what they called mushy stuff. So they focused on all the people parts of it. So they wanted to enjoy who they worked with and how they worked. So they actually made that a point of focus. And the third thing that they did, which was really surprising to me, is they took the most frustrating part of how they worked, which was changing requirements. And instead of kind of pushing it aside and saying like, we're just not going to have that anymore, you guys need to know what we're doing before you tell us to do it, they said, actually, we're going to turn that into a competitive advantage. So we're going to take this thing that we hate and we're going to turn it into how we work in the future. So they completely shifted their mindset about the thing that bothers them the most. And they came up with a whole, I mean, don't get me wrong, some of the stuff doesn't work, but it's a very powerful way, I thought, to actually think about the problem. So I won't go through these. These are basically summarizing what I just said. And they came up with a set of values. So I thought if we just took that idea of Agile, those concepts, those three things, forget about Scrum, forget about everything else, and we thought about analytics, could this help us think about what we do differently? So I thought of, now this should be done in a group setting, not just me standing up here, but I didn't have friends to go to Utah with to do this. So this is just the first pass. So to set a goal for analytics, I said, our highest priority is to enable a business to use data to drive better decisions through continuous delivery of actionable and accurate analytical assets. So that's our goal, that's our purpose. And then I said, we welcome changing requirements and follow-up questions, even late in the project. This means we're harnessing change and curiosity as a competitive advantage. So to me, as an analyst, one of the most frustrating parts was getting follow-up questions and all that kind of stuff. So I said, no, actually cultivating curiosity and encouraging people to ask questions. If we created a system that did that, then I actually think the way people interact with data could be very different. So what if we changed that, made that a competitive advantage? This is the mushy one. So can we make it about people and make sure people are happy doing what they're doing? And I think this one particularly applies to data quality. How can we be transparent about what we do? Be honest about what we do. You know, Naomi, you mentioned, you know, when you did this big change, you had to tell them like how long it's going to take. This is why we're doing it. And I think that kind of transparency or saying like, I don't know sometimes is also just a nice way to be open about what you're trying to do. And that's, these kind of summarize the four. I also came up with some values, but we can kind of skip those. So what does this actually mean in action? So this is not, you know, something like Scrum or Kanban that you can kind of take with you and package and go into a room and do it. these are designed to be just how you think about a lot of different things that you do. So how do you approach almost everything that you do? Do you follow these values when you do it? The same way, like, when you live, you have your own personal values that motivate you to do everything you do. Maybe we should have some in analytics that dictate how we work and how we work with the business in particular. So we've been kind of testing this out with some of the people that we work with. And so one of the things that's come up is the ad hoc request. So what used to happen with ad hoc requests, probably happens to all of us, is very async kind of process where somebody makes a request and then you go do something and then you give it back and then they have some questions and you wait. And this whole thing can just take days and days and days. And we did almost like a pair analytics test. So we were like, all right, instead of doing this async and you send it over and they give you responses back, if you just brought two of them together at the same time and you just did that, how long would that take? So for this particular case study, which is that the company called Tails, they went from something that would take 3 days to 1 hour. So you can cut that down entirely by just trying to be open and transparent and bringing people into the process. And instead of saying, I'm going to answer your question, you say, you're going to have many more of these questions. So let's just try to answer them now, as many as we can. The next one, which probably applies to you guys with data engineering, is how do we tell the story of data engineering when it's applicable? So one of the ways that we always used to do it was we'd have like data dictionaries and lookup tables and this kind of stuff and tried to give a lot of documentation to people about how to use tables, but it didn't really work very well. So one of the things that we've seen is like, if you take screenshots of the tools that they're used to using or root them in like this is the stakeholders, the world that they're used to living in, and then you show them in that context what tables mean, when do tables get updated, and that kind of thing, they can understand that model a lot more than they can understand a data model, which makes more sense to us. So how do you be transparent and think about telling the story from their perspective? And the last one, I don't have a screenshot for this. This is just something, again, one of our customers does called a data sweep. So instead of the request process, what she does every quarter, as she's head of analytics, how she decides what work is going to get done that quarter. She does have teams submit what kind of work she wants to be done ahead of time or they want to be done. And she reviews it and then she gets them all together and then says, this is the work we are going to do. This is how long we think it's going to take. And so you over here, you need to see that we're also doing this work for this team. And this is how long it's going to take. And we're doing this bit of engineering work because it's letting us do this thing for product. And here's why. And we're cutting it down. So they've completely opened up the process of how they decide what work to be done. And she said it's really changed how people respect her team. It's not just like, why haven't you done this for me? They understand what all they're being accountable for. And yeah, it's just been a nice, like, small shift that's really helped the team a lot. That's pretty much it, guys. Questions? I've got a question slide. No. I would say it'd be a really nice exercise to decide what values your team wants to operate under. Like, how do you want this to work? And then you can figure out what are the biggest things that are changing that. I think if you just go by what's causing you the biggest pain, then you would end up cutting a lot of things out, like questions and that kind of stuff, which is what we do. We react and like pull in instead of saying, how do we really want to work? And then go about it that way. So say have that session with your team and see what does the team think your values should be, your principles should be. Yeah. Yeah. Yeah, that's a good question. I mean, it does probably depend on the request itself. I think in this case, they were trying to get to he was trying to make a decision about something before he went into a meeting. So he didn't necessarily need like, give me a graph for this presentation. he was kind of like, I need to go tell them why we're going to do A or B. Can you help me work this out? And then I think after that, there were probably some assets that helped with that. But instead of saying, you know, he would have asked one question at a time, kind of thing, like, oh, I think this. Can you tell me this? Okay, well, that's led to 4 more questions, and you just keep extending the life of this question. So yeah, I think there's a lot of, so my take on that personally, I think there's a lot of people who want the stakeholders to just be better at asking questions. And there's a big kind of push around how do you get stakeholders to ask better questions? And there's probably something that you can do about that. But I mean, if we think about how we work with data, how often do we know the questions that are going to be meaningful when we're working with it? We don't know. That's the process of exploration. And so by forcing a lot of upfront, you're inherently reducing the amount of exploration that they can do. So I think you've got to recognize that trade-off with whatever system it is. And I think it's probably realistic to just say, like, we need to set aside some kind of way for them to explore with us. And then, yes, there are some things that need to be like, you can't do everything this way. You never get anything done. So you do have to draw a line and be like, okay, you want a report? That's very clear cut. Let's build a report. But even that process, you could shorten that and make it less of a waterfall development and more of a like, okay, I've got a mock-up for you. What do you think of the mock-up? Like, check in a lot more frequently with what you do. Does that make sense? Anything else? Pizza?
Thank you very much, Taylor. That was a great headline act. And I want to thank everyone for coming. You've been a great audience for some introverted speakers. And pizza should be here very soon. So I'm looking forward to hang out with you and have a chat. And great, thanks for coming.